Good evening, everyone. Myself, Sri Lakshmi. I am a PhD scholar from IIT Bombay. This is our second tutorial session for the course Principles of Organic Synthesis by Professor Punniyamurthy from IIT Guwahati. I hope uh, my audio is audible and I'm audible and my screen is visible.
Yes, audio is visible, screen is visible.
Okay, so now let's move on to today's discussion. In week one, we have seen the formation of aliphatic carbon-carbon bonds by some base catalyzed reactions. And in the last week lectures, that is week two lectures, we have seen the formation of aliphatic carbon-carbon bonds by some acid catalyzed reactions as well as some base catalyzed reactions. In that, we have seen the reactions of enolates, and again, we have seen the discussion between the kinetic enolates and thermodynamic enolates, and we have came across some named reactions like Robinson annihilation, Michael reaction, and then in the acid catalyzed reactions, we have seen the reactions of alkenes, carbonyl compounds in presence of an acid. That is, an electrophile is being generated in the presence of an acid. The condensation of alkenes and several other reactions which is catalyzed by acids, like managed reactions, also we saw in the lectures. So today, first we will see some of the reactions that have been discussed in the last week lecture. So one reaction was Michael reaction. Okay, so in Michael reaction, what is actually happening is uh, a carbonyl compound having an alpha hydrogen. So an enolate is generated, and this enolate will act as a nucleophile, and it is attacking on the alpha beta unsaturated carbonyl compounds, that is acting as the electrophile. So this type of reaction is known as Michael reaction. So there, this enolate we call as a Michael donor, and this alpha beta unsaturated carbonyl compound we call usually as a Michael acceptor. So this is the reaction between a Michael donor and Michael acceptor. And one application, Michael reaction is a type of conjugate addition. And one more thing is that the application of Michael reaction is another reaction, that is Robinson annihilation. So in Robinson annihilation, what is happening is that we have already discussed this. First, this kind of a conjugate addition of alpha beta unsaturated carbonyl compound will take place, followed by an aldol type of reaction and dehydration to get this type of bicyclic derivative. So that is Robinson annihilation. That is basically Michael reaction followed by aldol condensation. Then another reaction which is catalyzed by acid we have seen is managed reaction. So here what is happening is there is a ketone, aldehyde and secondary amine, and in presence of acid followed by this basic hydrolysis, we will be getting this beta amino alkyl carbonyl compound. So it is basically the condensation of an aldehyde or ketone which is in the form of enol. So this will be in the form of an enol with an iminium ion. So iminium ion is basically produced by the reaction between this aldehyde and the secondary amine, which results in the beta amino alkyl carbonyl compounds. So this reactions proceeds through this mechanism. First, iminium ion formation will take place between this aldehyde and the secondary amine, and parallelly, this ketone will undergo enolization to get this enol, and then this enol will be attacking this whatever formed iminium ion to get this type of intermediate, and after that then proton transfer will result in this salt, that we call salt of Manish base. And then this in presence of base, this proton will be taken up by a base to form this compound which is known as Manish base. That is basically beta amino alkyl carbonyl compound, which is the final product of a Manish reaction. And then another reaction which we see was mechanism of acid catalyzed halogenation of ketone. So first, in presence of acid, this ketone will generate its corresponding enol, and then halogenation will occur. That is, this bond will fall here, and this double bond will take up the Br plus, and Br minus will leave out to give this halo keto compounds. So that are some of the reactions which we saw in the last week lectures. So today we will first discuss some questions to brush up whatever we have discussed in the last tutorial session. So yeah, directly we will go through some basic questions first. So anyone can answer this. Which of the following is the essential condition for aldol reaction? Presence of beta hydrogens, presence of alpha hydrogens, presence of carbon atoms, all of the above. It's very simple, basic reaction.
All of the above.
The question I just brush up whatever things we have discussed.
All of the above, madam.
Am I audible?
Yes, yes, madam. All of the above. Hello, ma'am. Can you able to hear us? Hello, ma'am. Can you able to hear us?
Yes, 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 I can hear.
All of the above, madam.
Yeah, all of the above. And what is the primary essential criteria that we will tell us?
Alpha hydrogen.
Yes, presence of alpha
Alpha
hydrogen.
hydrogen.
Yeah.
Yes.
So the answer is presence of alpha hydrogen. Now the next question. Out of this, which is the aldol reaction? This also so this is the reaction between two both this is the reaction between two aldehydes and this is the reaction between two ketones. So is this an aldol reaction?
Yes, madam.
Okay, and this one?
First, done. This one also allal.
Yes. So both are aldol reactions.
Allal
Yeah.
reactions.
So the next is if dehydration step occurs in continuation of aldol reaction, then what we call such type of reaction?
That is called Perkin reaction.
Uh,
Alpha beta. Dehydration. Dehydration.
Dehydration or
Dehydration. Elimination
uh,
of water.
yeah, it is dehydration step is occurring in aldol reaction. So
Hmm.
basically we
It's
are
a
calling
condensation.
yeah, condensation
Condensation
reaction.
reaction. Okay.
Yeah, aldol condensation reaction.
Yes, yes.
Okay. And then this reaction of acetaldehyde and propanol in presence of aqueous base. So which type of reaction it is? Self-aldol, crossed-aldol, intramolecular aldol or Cannizzaro reaction?
Self-allal reaction.
Self-aldol means it will be like if two molecules of acetaldehyde is reacting, then we will call that self-aldol
Self-allal.
reaction. Yeah.
Cross-allal.
Yeah, it's a cross-aldol
Cross-allal reaction. Two aldehydes,
reaction.
different
Yeah,
aldehydes.
both are different substrates. And
Hmm.
intramolecular means both the constants are present in the same compound. Okay, so this is an example for crossed aldol reaction.
Okay.
Now, which of the following carbonyl compounds undergoes intramolecular aldol reactions? For intramolecular, we know
All the above, madam.
uh, for intramolecular, this compound is having only one aldehyde, this is having only ketone, and this is dicarbonyl compounds, or all of the above. So, which one will be needed for intramolecular aldol?
Dicarbonyl
Yes,
compounds.
dicarbonyl compounds because if two carbonyl groups are not there, it is not possible to undergo intramolecular aldol reaction, right?
Yes, correct.
Yeah. And next one, okay, this we haven't discussed, but if you know, we can just brush up this also. When two molecules of benzaldehyde, when treated with concentrated KOH, gives one oxidized product and one reduced product. The reaction is called
Cannizzaro reaction.
Cannizzaro reaction. So basically, what is happening there in aldol, we saw that it needs an alpha hydrogen, right?
Yes.
So in the case of compounds, aldehydes having no alpha hydrogen, when we treat it with base, we will get the one carboxylic acid and one primary alcohol. So this oxidized product is the carboxylic acid and reduced product is primary alcohol. So both we are getting from one same reaction. That is basically Cannizzaro reaction. I will show that. This is the Cannizzaro reaction. So this is having no alpha hydrogens. When we treat it with base followed by this hydrolysis, we will get this acid and this alcohol. So what is happening here is first this base will abstract this base will this OH minus will attack this carbonyl carbon and forming this kind of anion, and then through this intermediate it will again, this O minus will come here and this will again attack the same compound, like second molecule of the same compound, forming one this alcohol and this carboxylate anion, which upon hydrolysis will give this carboxylic acid. So this reaction is known as Cannizzaro reaction. Is it okay? Okay. Now, yeah, so we have seen this Cannizzaro reaction. So basically what is happening, this hydrate anion is forming, then intramolecular hydrate shift is happening, which is resulting in this alcohol and this carboxylate anion. So the next question is, what is the key step of Cannizzaro reaction mechanism?
All the above, madam.
All the above, but what is the key step? Because this
Nucleophilic addition of hydroxide ion. First,
nucleophilic addition of hydroxide ion, yes, and but here there is no deprotonation by base, right? Here OH minus is undergoing nucleophilic addition.
yes.
Yeah, and this is also there. Hydride transfer is also there, right? That is also one of the crucial step. This intermolecular hydride shift. That is, this hydride is getting transported to this one. Okay, so these two are the answers: nucleophilic addition and hydrate transfer are the key steps in Cannizzaro reaction. And so it is basically which type of reaction: condensation reaction, disproportionation reaction, oxidation reaction, reduction reaction, which one it is?
Disproportionation reaction.
Yes, disproportionation reaction. And we can,
Oxidation and
yeah, oxidation and
uh,
reduction is happening in
yes.
same compound or same
Yes.
reaction mixture.
Yes.
Yeah. So the reduced product of the Cannizzaro reaction is
Yeah, alcohol.
primary alcoholic
Primary
acid.
alcohol.
Yeah. And the oxidized product is
Carboxylic acid.
carboxylic
Carboxylic
acid.
acid.
Okay. Yeah. Now, these are the answers for those questions. Yeah, now maybe you can try these reactions. What will be the product of this Robinson annulation reaction?
Six member ring it will come.
Yeah, six membered ring and the
That double with
substituent.
double bond. Methyl.
Yes. So maybe you can try drawing that. I will draw here anyway, and you can cross check with that. We'll try to draw here. Okay, it's little difficult to draw here. I hope you understand.
Yes, ma'am. No problem.
Here one ketone will be there. Methyl will come here, and here will be the second ketone. So this is okay.
Yes, madam.
Okay. And what will be the difference between first product and the second product?
There is no methyl here.
There is no
Substitution.
methyl in this substituent, but there is
Yeah.
one extra carbon here, right?
Yes, yes.
So where it will be coming?
The ethyl will come. Keto.
You can just try drawing the intermediate. So here the methyl will be coming here, right?
Yes, yes.
Yeah. I hope it's clear. Now maybe you can try this. Predict the product for each Michael reaction below. So Michael reaction, what will be happening?
First protonation will.
Yeah, deprotonation will happen.
Mm.
So from where proton will be abstracting first?
CH2 that.
Yeah. So
Yes.
anion will be generated here, right?
Yes.
Then
It will go attack to carbonyl group.
yes. So like this substituent will come here, right, in this middle position.
Yes.
Yeah. And second one, if there is any doubt, you can ask in the final answer. Should I draw here or it's okay?
Wait, madam, we are trying.
Okay, okay, fine, fine. Let me know whether you are also getting this answer. I got this.
Yes, madam.
Okay. The next one. If you're stuck in between any step or any intermediate, let me know.
Madam, in this second equation, carbonyl compound will form in the five-membered ring nearby first position. Correct, no? The
There
double
where
bond
it
is
will
there.
be forming. Like which proton is more acidic? Which compound is having more acidic proton?
Alpha hydrogen double bond.
But see this compound, it is having two electron withdrawing groups, right? This is an
No.
active methylene compound, right?
Yes,
So
ma'am.
these two protons will be more acidic. So first anion will be generated here and then it will undergo conjugate addition to this sender. Second
Madam,
one is okay. Huh.
why after forming the carbonyl compound, why it will attack in the five-membered ring downside of the second position? Why can't it attack in the first position? That means alpha position.
Like you, whatever you are telling us here.
Not here. Next one. Yes, ma'am.
Here.
Ortho. Yeah, ortho position. Yes,
Okay.
ma'am.
So here what is happening is that this is already an alpha beta unsaturated carbonyl compound, right?
Okay.
So this double bond will also have a tendency, more tendency to undergo in delocalization.
Hmm.
So this is always having a tendency to shift to here, and this will always have a tendency to undergo resonance like this
Okay.
once the enol is formed.
Hmm.
So abstraction of proton from here will be more favored than this ortho position in the case
Okay.
of alpha beta unsaturated carbonyl compounds.
Okay. Hmm.
That's why we call this reaction conjugate addition. That is basically a 1,4 addition. And last class, I think someone mentioned about this. This is basically a soft interaction, we can tell.
Okay.
Yeah. So it's okay, you got this?
Yes, ma'am. I got.
Okay. So you can try the last one as well.
In case of this case also beta position only will attack.
Yes,
Here
yes,
also.
yes.
Yes. Okay.
Here we have given, right, this is Michael reaction. So Michael
Yes.
reaction, everything it is,
Beta position.
yeah. I think first one I draw here wrongly. This will also be attacking here only.
Yeah, yeah, yes.
Yeah,
First one is
yeah, yeah.
yes,
One for
beta position.
position only. Yeah. I hope this is clear for you. So here, first anion will be generated, and that will attack here at the center.
Hmm. Okay.
Okay.
Yes, ma'am.
Okay.
Here one methyl coming by methyl here. That is it will
Uh,
not come na methyl group. You kept a methyl.
this is actually, yeah, it will not be
Yeah.
there. Yeah, yeah,
Ah, yeah,
yeah,
yeah.
it will not
Ah,
be there. Yeah.
yes, yes.
Okay. Yeah, now you can try this. Predict the major organic compound formed from each of this Claisen condensation reaction. Yeah. Four questions are there. You can try. So here, from where proton abstraction will take place?
Keto 2 adds CH2.
Yes, this one. And then this anion will attack the second molecule.
Second molecule.
Yeah. It's okay, or should I draw the answer?
We are writing, madam.
Okay.
Just OIT will go and diketo compound will come.
Yes, like one side ester and one side keto compound will be
Yes.
formed.
Yes.
Yeah.
That CH2 attached to CO,
Yes.
CH2 it will come.
I will draw here. You can try parallel in second one also. Is it okay? First one?
Yes, madam. Okay.
Okay. So second one, from where proton will be abstracted?
That CH2, keto 2 adds
Yes,
CH2.
because this compound is not having any alpha hydrogen, right?
Yes.
Yeah. So only possibility is anion forming here and then enolate forming.
After OME will eliminate
Yeah.
methanol.
Yeah. One molecule
PH
of methanol will eliminate.
PSCO
Huh.
CH methyl COME.
Yes, yes, yes.
Ma'am, OCH3 from which compound it will go? Whether from phenyl compound or methyl compound?
Which one it will be forming? Just try. Like this will attack here, right?
Okay.
And then this will go here. Once this will come back, this OCH3 will be leaving.
Okay.
Okay, so here this ketone will be regenerated, but this OCH3 will get eliminated.
Okay.
Okay, so it will be PH, uh, C double bond O,
If
Yeah, you can ask.
third one is that CH2 attached to COET will come answer. One OET will eliminate.
Yeah,
COET will come.
yeah, that
Third,
is here this ortho position, one
hydrogen.
CO2 ET will be coming, right?
Yes.
Yeah, that is right. Because here also this compound is not having any alpha
Alpha
hydrogen.
hydrogen.
Yeah, we can try this. So here which one will be abstracted?
That CH3 is there. That
Yes.
one.
So here
Alpha
will,
alpha
yeah.
hydro alpha hydrogen.
Then it will attack here,
OET will eliminate.
eliminate. So what will be the product?
CH2 CO.
Huh.
Come. PHCO
Hmm.
CH2
Yeah.
double bond with methyl.
Yeah. So pH, C double bond O, then the
C,
CH2, C double bond O,
C,
and this group. Yeah.
yes,
Yeah. So we can move forward, right? I think now everything is clear about Leysen aldol reaction.
yes, madam.
Yeah.
Yes, ma'am. Okay.
Now we will solve some problems related to last week lectures. So first one is this one. This HBr mediated reaction. Major product of the reaction is which one?
The second one, madam. Second one.
What is happening here actually?
Second, the tertiary carbocation will form after bromo will go and attack nucleophile.
Mm, tertiary carbo. Okay, so you what you we are expecting is this will be taking one proton, right here.
Yes, madam.
So here if single bond, this will be forming, right? This carbocation will be the intermediate.
Yes.
But there is one double bond in nearby position, right? So directly Br minus will not go and attack the sender. What is happening here is this double bond will stabilize this carbocation. Okay. If
Okay.
there was no adjacent double bond, then we can expect okay, Br minus will go and attack and stabilize this carbocation. But here, what is happening? This double bond will shift to here, and this Br minus will be attacking at this center.
Okay.
Okay. So that is what is happening. First, this carbocation will be forming. Then this double bond migration will take place. That will be quenched with this Br minus to form this pentyl bromide.
But tertiary carbocation is more stable.
Why is tertiary carbocation more stable? What you asked?
Tertiary carbocation, whatever first intermediate form that is tertiary carbocation,
Yes,
this is
yes.
that one is more stable.
Huh.
That's why I thought second one is the answer.
Yeah, the intermediate is same only. So because if here carbocation is forming, that will be secondary, right?
Yes, madam.
So it is not going through that intermediate. First, tertiary carbocation is forming, but there is an additional stabilizing factor for that tertiary carbocation here.
Okay.
That's why here it is going through this one. Okay.
Okay.
Yeah. Next one, this one. I think this is not discussed in last class, but you can try the major product of the reaction.
Third one is answer, madam.
Third one. So how it is going? You can explain.
First, OH will eliminate. First, protonation will happen.
Yeah.
After double bond, it will form.
Okay.
After the double bond, CH2, CH3 one proton will eliminate. It will form double bond.
But how this methyl is shifting? Like third one you
Carbo,
said, right?
carbocation will form now. That
Yes,
methyl
yes,
group
yes.
migrate from here.
Yeah. So that is going through this. First, this water molecule will leave, resulting in a carbocation at the center.
Yes, madam.
To that center, this methyl group will be migrating.
Yes, madam.
That will form one
Uh,
carbocation here at the center.
yes, exactly.
Then a proton
Ah,
elimination will give the product C.
Yes.
So this is happening. First a secondary carbocation, then it will, this methyl migration, the driving force is that it will form more stable tertiary carbocation. Then
Yes.
even elimination will give this product. Next question. The major product of the reaction. So this compound on treatment with this trifluoroacetic acid, out of this, which one will be the major product?
Second one, madam.
Yeah, second one. Okay, you can explain how it's forming.
First to trifluoroacetic acid first will form proteination
Yes,
keto.
yeah.
After this double one will migrate.
Yes, this double bond will
Carbo-
migrate to here and that
that OH,
carbocation will be stabilized.
yes.
Yeah, then
Phenyl group will migrate there.
so
Phenyl group.
here one carbocation is forming. So then
Yes.
there is two possibilities, right?
Mm.
Phenyl group can migrate or ester group can migrate. So if phenyl group is migrating, we will get this one. If ester is migrating, we will get option A. So which
But
will be more feasible?
phenyl is more migrating after to compare to ester.
Yeah, but here one more thing we have to do, we have to think is like this
Para position.
para position
Para
phenyl.
position is more stable.
Yeah, when this carbocation is coming near this phenyl ring, it will be more stabilized, right?
Okay.
So it will be going through this intermediate because phenyl ring is also having electron delocalization. So this carbocation will be stabilized by that electron delocalization.
Okay.
Like as we can see this in case of CO2 ET also there is conjugation, but compared to that, this phenyl group is having more conjugation. So here we are not considering the migratory aptitude. Here we are considering the stabilizing factor of the carbocation.
Okay.
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 Yeah. So this will be the answer. Option A. Next one, the major product of the reaction. So this alkene and this formaldehyde in presence of acid.
నాన్న ఈ రబ్ బుక్ లో హిందీ రాయమని నాన్న ప్రాక్టీస్ రబ్ బుక్ అనేది మళ్ళీ నా ఈవీఎస్ లో ఆల్రెడీ మీకు డ్రా చేసింది దాంట్లో ప్లాన్ ఏదో చేసింది అది డ్రా చేయి
First one, madam. First one.
ఇంగ్లీష్ లో
Can you
రాయాలి
explain?
నోట్బుక్ లో రాయాలి
Formaldehyde first it will form a proteination with water.
కూడా ఉంది డ్రా
Okay.
చేసావా ప్లాన్ లో
The double one will go and attack to that formaldehyde.
This double bond. Okay.
Methyl attached to carbon it will get positive charge.
Huh. Like one here it will form positive charge.
Yes, madam.
Yeah. Then you are expecting elimination will happen.
Yeah, yes, yes.
Okay, we'll see. So, but this is the answer. So, first, whatever intermediate is forming, that is right.
Okay.
So, HCHO, H plus, it will form this kind of intermediate. This oxoanion will be forming, which is resonance stabilized with this. Right.
Okay.
Now, this double bond will go and attack this carbon, and this is forming. And so, this carbocation here, we are not using any base, right?
Okay.
Cannot take this proton. So what is
Okay.
happening? Since there is excess of water, second molecule of water or OH minus, we can say it will go and attack here, leaving one H plus ion, forming this compound. Okay.
Okay.
Then this is kind of protection, right? Diol we are protecting with aldehyde to get
Formic
this
acid.
compound. Yeah.
Acidity.
So this is an example for acid catalyzed Prince reaction. So first intermediate, as we expect, it is forming. So up to here, whatever we are expecting, it is happening. But here, since we are not using any base, this proton abstraction will not be much feasible. Water molecule will be going and attacking this carbocation. And then this 1,3-diol. 1,3-diol will be protected with this formaldehyde to give this compound. Is it fine?
Okay, fine.
Yeah. We'll move on. Yeah, this last week also we have solved this problem. Which reaction it is?
Fourth one answer, madam. This one is it's not fourth one. 1, 2, 3, 4. Glycogen conjugation. This one.
Claisen or intramolecular, we will say another name.
Yes, intramolecular glycogen conjugation.
That is one name is there, right? Dickman condensation.
Dickman.
Yeah. So which one will be the answer?
Second one.
Second one. Okay. We'll see. But here there is some difference. Like
Okay, okay.
after
Water is there.
electrolysis, what we are
Heating.
doing, heating also we are doing. So
Fourth one will get answer.
fourth one, sure.
Yes.
Actually, here heating, this decarbonylation is happening. Carbon dioxide is eliminating. Like whatever. So first, in the first step, we can say this is forming.
Okay.
That is clear, right? So it will generate anion here that will attack this carbon. Then OET will be leaving to form this one. Okay.
Yes,
But
madam.
while heating, the carbon dioxide is eliminated from this one. So that will result in this option C. Okay.
Okay.
Yeah. Next question is this one. I think this we have seen in the last week lecture video. This alkene reaction with this acid and how we can determine the stereochemistry also. You can try drawing this and then let me know.
Okay.
Yeah.
హలో చెప్తానా హిందీ తను ఇంకా రాలేదు అనుకుంటున్నాను రాత్రి ఈరోజు హిందీ నా పుస్తకం పెట్టాలి పుణ్య రాస్తాడు చదువుతానా రాసు పేజీ నోట్బుక్ లో రానా నోట్బుక్ లో రాయి ఓకేనా ఓకే
Fourth one, madam.
Fourth one, how? You can tell.
First, the COM is there. First, sulfuric acid will form a protonation.
Okay, but that is ester, right?
Yes, sir, madam.
Uh,
Keto.
it's not ketone, so that protonation will not be that much feasible because that oxygen, like this OMe, is coordinated with that carbonyl, so that proton coordination will not be that much feasible as
Okay.
compared to aldehydes and ketones. What is the other possibility here?
Double bond. It will first proton will go and a double bond it will.
Yeah, so which double bond? The three double bonds are there.
First one. First
Yeah,
this one.
okay.
Yeah.
First double bond will go and attack go and take up a proton.
Hmm.
So that will create a tertiary carbocation, right, at the center.
Yes. Yes. Yes.
Then what will be happening?
Then it will go attack to ester.
It will go and attack. How it will go and attack? It is a carbocation, right? It's an electrophilic sender. So something should come and attack on this sender.
Just a carbonyl group will oxygen lone pairs is there that one will, I believe.
Then there also problem is that it is an ester group, right?
Okay.
Yeah,
I think it will attack with the second double bond.
yeah, that is possible. Second double bond,
Okay.
but through which position? This carbon or this carbon?
More first carbon that methyl is attached.
This one.
Hmm.
But there, what we have to see is if it is attacking through here, what is
Hmm.
forming is a secondary carbocation, right?
Okay.
So if it is attacking through this second sender, what will be forming?
Tertiary carbocation.
Tertiary carbocation. So which will
Hmm.
be more possible?
Tertiary carbocation is more stable.
So it will be attacking through this sender, right? So that
Okay.
will form a carbocation here. So how many membered ring is formed now? One, two, three,
Two,
four, five, six membered
six.
form. Six membered ring, one with one methyl group and this group, two dimethyl group. So what we got now is here dimethyl group is there. Here one methyl is there, and mm, then the remaining part is also remaining as such. Okay, now next what will be happening? So this carbocation again can be stabilized, right?
Yes, the double bond will
Yeah. So here
the
also,
double bond
yes,
will go and attack.
double bond will go and attack, and that will form a bicyclic compound. Like I'm not drawing, like this kind of a bicyclic compound will be forming. But then we have to see what is the stereochemistry, like whether the junction is cis or trans, and this junction methyl group and CO2MA is cis or trans. How we can tell that?
Trans, I think Declin's trans is more.
Yeah, decalene trans is preferred, and the relation between methyl and ester, what it will be? Whether it will be like in trans form or cis form.
Transform.
But we heard we don't have any option like that, right? This is cis decalene.
Yes.
So we know transdecalene is more stable than cisdecalene, so we can expect this one. But here, why the stereochemistry is cis? This methyl and this ester is in cis conformation, and this ester and this OH is cis trans conformation. And from where this OH is coming,
That
like whatever carbocation will be present at
it
last, that will be quenched by this water present here. Okay, I think I have pasted the lecture video. Yeah, like this. So if you have gone through the lecture video, you can see sir explain through this chair transition state. You remember?
yes, yes.
Yeah. So here what is happening? So this is our starting material, whatever is shown here. So what will happen is first the protonation will take place, and here carbocation will be formed. This carbocation, and this carbocation, this second alkene will attack this carbocation to form this compound with this tertiary carbocation. Then the third alkene will be attacking that center to form this compound and a carbocation at this center. And here, whatever carbocation is formed, that is attacked by one water molecule from the reaction medium. So here OH will be coming. So if we draw the chair conformation, the stereochemistry also we can explain. So here, as we can see, this methyl is upwards, this proton is downwards, right?
Yes.
In junction. So that will create a trans ring junction. And as here we can see, this ester is actually equatorial and this OH is equatorial, but 1 to di-equatorial means it will be in trans. So the relation between this ester and this OH will be trans. And here this methyl is axial and this ester is equatorial. And 1 to axial equatorial in chair conformation, it is cis. So here it is drawn as cis. Both are in cis conformation. You can go through that once again. If any doubt is there in between, maybe you can try drawing as well.
Okay.
Then let me know whether you have any doubt. Now itself you can try. Just draw the starting material in this form. And this also you can try this. One more example is given here, that one as well. Product we can predict, but stereochemistry also matters in these cases.
Yes, sir, exactly. Stereochemistry will do
Yeah.
mistakes.
You try this one as well and let me know whether you are able to reach the correct stereochemistry or not.
దానికైతే అది పిలుస్తారు అయిపోయింది ఏమి దాని మిడిల్లో బ్యాటింగ్ తీసుకుంటారు ఆ బ్యాటింగ్
Are you able to reach there?
Still, we are in confusion and axial equatorial positions.
Okay, like a
Mhm.
final compound you are able to reach, or in between you are stuck?
Yeah, we reached means whatever written, that same manner we reached, but
Huh.
axial equatorial.
Axial equatorial, if that is difficult, one thing we can do is like just see this structure, and here
Mhm.
the CO2Me is upwards, right?
Yes, sir.
And this OH we have written downwards.
Okay.
Yes. So why this OH is attacking from downside means the CO2Me and this methyl is upside creating hindrance.
Still condense. Okay.
Yeah, steric hindrance. That's why this OH is attacking downside.
Okay.
So whatever stereochemistry this methyl and CO2Me is having, this water molecule will be coming from opposite direction. So that will be always in trans manner. The
Yes, one.
CO2Me and this OH and this methyl and OH.
Yeah, one two axial equatorial.
Yes, yes. 1 to
Trans.
axial equatorial will be trans. And here this methyl and CO2Me is upwards. That is 1 to this is 1 to axial equatorial actually. Here this is downwards, right?
Yes.
So this is in cis form and this will be in trans form. So if you are not able to draw this first structure for this, what you can do is just draw three chair forms consecutively and then put double bond wherever needed and erase. Like what I can show is a chair will not be proper here. Like this you can draw, and if I am removing that way. Okay, like that you can draw and just rub whatever portions are not needed and put double bond there. Then you can create the starting material. I think if starting material we can draw in the proper chair form, then it is not that difficult, right?
Yes. Yes.
Yeah. Let me know. Maybe I can draw, by next class I will explain this problem as well. I will draw properly and I will share it with you. Is that okay?
Okay.
Or parallelly you
Okay.
can also try once again. Take your time and try whether you are able to reach here or not.
Okay.
Is this clear? Whatever we explained here, this question. Or
Yes, madam. That one
there
is
also
clear.
stereochemistry is creating confusion?
Stereochemistry little confusion only, madam.
Yeah, stereochemistry actually what we have to see here is this is actually
Trans.
this group and this group is in trans position, right? So whatever form we are drawing in that also it should be in trans. So this CO2Me and this group is in opposite direction. So here yeah, here it's okay, and here also we have to see that. Where that, yeah, this methyl group and this group that is in cis position, right?
Yeah, this is.
This methyl and this. So here also we have drawn like that only, like this methyl group and this group are in cis position. So while drawing, we have to take care of that thing only, whether the double bond is in trans or cis. Because if we draw that wrongly, entire stereochemistry will be also wrong. If the concept
Okay,
is
ma'am.
clear, you can go through this once again and try. By trying
Sure,
it,
ma'am.
you will be clear about this. Yeah.
Okay, sure.
Now next is the major product of the reaction. So here benzaldehyde is there and this ketone is there. So what will be happening? reaction it is.
Fourth one, madam.
Yeah, you can explain how it's forming.
First HCl, it will go aldehyde first protonation.
Aldehyde or ketone, which will be undergoing protonation first?
Ketone only will go first protonation.
Yeah,
Ketone,
why?
because of the ethyl is there, na, electron donating group.
Yeah, and there is alpha hydrogen as well, right?
No, alpha. Yes, alpha
So
hydrogen.
it can form enol as well.
Yes, sir.
So once it is protonated means this can shift to here, and this oxonium ion will be stabilized also.
Yes.
Okay, so it will form double bond here, and then that enol will be attacking,
Benzaldehyde.
yeah, benzaldehyde
Al-
carbon. So which reaction it is basically?
this is
Aldol, right?
oh, all reaction,
Yeah,
but all
because
reaction is breaking basic medium, but here
yeah, this is
acidic
acid
medium. Uh,
catalyzed aldol reaction. Yeah,
all reaction.
aldol
Yes.
is possible in presence of base as well as acid.
Yes. Yes.
Yeah. So in base, whatever we are seeing is enolate anion will be the intermediate. In
Yes.
acid catalyzed medium, proper enol will be the intermediate.
Yes, ma'am.
Yeah. So last one will be the answer. This is the example for acid catalyzed aldol condensation reaction. Clear?
Clear, ma'am.
Okay. Yeah, it's aldol condensation, right? Then water molecule is also getting eliminated. Once it is attacking at this carbon, that OH will be forming, then elimination will be resulting in this double bond. Next one, the major product of this reaction.
Sodium hydroxide methyl halide.
Yeah.
Fourth one, madam.
Fourth one, dimethylation we are expecting.
Methylation. No, no. Fourth methyl not, madam. One methyl. No. One. First one. First one.
Okay. So you can explain.
That's keto addition attached to CH2 first will generate carbon ion.
So here, right?
Ah, yes, yes.
Huh. That
The
will be
carbon ion.
attacking on this methyl iodide,
Yes, yes.
and iodine will be eliminated. So
Yes, madam.
here, what we have to think is that this proton is will generate kinetic enolate or thermodynamic enolate.
Kinetic inhibitor, that is
Kinetic
less
enolate.
steer. Hmm.
Yeah, but this is not bulky base or anything, right?
Okay.
So it is more feasible to take the hindered proton or not easily abstractable proton as well. So if we are using some bulky bases like LDA or something, something that time this is more feasible proton because LDA is very bulky base. But
Okay.
here this can take this proton actually.
Okay.
So what will happen is that there is a possibility of this extended conjugation. This will go here. This will go here and this will go here. Okay.
Okay.
So whatever intermediate is forming first is this double bond will go here. This double bond will come here, and here this O minus will be generated. And then what will be happening?
Methylated
Where it will attack?
beta position means here this
Here
double bond.
or here?
Second one, whatever you kept that
Here, right? Or here?
here, yeah. Now you kept there. Yes, madam.
But that is not happening. Actually, what is happening? This will go here, and this double
Okay.
bond will stay intact, and this will be quenched with this
Okay. Second
methyl
one.
group. Yeah, here methyl. So this is what is happening, because this carbanion, whatever it is forming, will be more polarized because of this presence of this nearby oxygen group.
Okay.
So that is why it is first it is forming anion here, but then this will form here and this will come here, enolate will generate, and then that enolate will be quenched through the second position, that is alpha 2 carbonyl group. Is it okay?
Okay.
Yeah.
Okay.
Now this one, the major product of the reaction. So here a ketoester is there, and here this alpha beta unsaturated carbonyl compound is there. So in presence of NaOH, what will be happening? So here which proton will be abstracted first?
The key to attach to 5 ring CH2.
This one.
Yes.
Okay, if this is attacking,
It will attack beta position of double bond.
here we are expecting.
Mm-hmm.
Then we should get, I think, this one, right?
1, 2, 3, 4, 5.
Or no, it will be like here CH2, C double bond O. But which one is more acidic here? This is forming actually. Maybe with product we can try to see how it is working. Answer is there, product is there. Let me know how it is going through. So you told this proton is acidic, right? This proton is
Yes, man.
getting deprotonated. But here you see, here also
Yeah,
a
yeah.
proton is there.
Yes.
This,
That one only.
yeah,
That proton only
both
will take.
sides electron withdrawing group are there. So that will
That one.
be more acidic one.
Yeah, that will take, madam. Double bond will form. Inolate will form. Inolate
Yeah,
will come attack here this double bond.
alpha position. Yeah. Then what is happening? Which reaction it is? So first Michael addition happened, then
Michael.
uh,
Michael. Robinson elimination. Michael elimination
Robinson
followed by
addition. Yes.
Robinson.
Yeah. So once that Michael reaction happened, then there is possibility of an aldol reaction, right?
Yes, Michael elimination followed by all reaction.
Aldol reaction. That will give this one. Is it okay?
Okay, man.
Now this one, the major product of the reaction. So this ketone in presence of LDA, THF and this ethyl bromide.
The second one, madam. Second one.
Second one, so here, second one should be going through this, right?
Hmm.
This will attack this carbon and Br minus will be leaving. That you're expecting, right?
Yes.
But as I told, LDA is a very bulky base.
Okay. Means
So,
sterically less than itself.
yeah, sterically, whichever side is less hindered, it will be always taking that proton. So here, this methyl is more free, right?
Okay.
Compared to this ethyl because it is in between. So it will
Okay.
be taking this one. So which will be the answer then? If it's forming anion here, so in these cases we should be careful which base they have given as well.
Pardon, madam. Which base?
Which base they have given, because if it was any other base, it is not necessary that it should take proton from this side. But since it's LDA, that means it will always take proton from less hindered side.
Okay.
Like previously we have seen, right? See, if
Yeah.
here also we are using LDA, means this is a little hindered proton for LDA. It will prefer to take this proton only. So wherever acidic proton is there, that is less sterically hindered, LDA will take that proton. Okay.
Okay.
So which one will be the answer here? Just this here CH2 will attack
Third.
the CH2.
First one,
Yeah, first
first
one.
one, first
Yeah,
one,
yeah.
first one.
So kinetic enolate will be formed with LDA because it is a strong non-nucleophilic base that removes proton from the less substituted alpha carbon, forming this enolate, and that will be quenched with this ethyl bromide to get this. So clear?
Yes.
Clear.
Okay, so I have said that much questions for today. In between, if you have any confusions or doubt, you can ask now. Should I explain any question once again?
No, madam.
Okay. So if it's okay, maybe we can see next week with some more problems. Okay.
Oh, okay, madam.
Yeah. Thank you for joining.
Thank
Thank
you,
you,
madam.
madam.
Yeah. Thank
Thank
you.
you.